All right, so this video is going to cover how to find the perimeter and areas of figures in coordinate planes, and most of this is just going to be perimeters, but I digress. So just real quick, cover all the basic stuff that we need. So our distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And then our slope formula is y2 minus y1 over x2 minus x1. And Pythagorean Theorem is a squared. Ooh, that was bad A. A squared plus b squared equals c squared. And by the way, all of these can come in handy later on today. So the difference between the area of a figure and the perimeter of a figure is that area is the amount of space you have inside. And then perimeter is your distance around the outside. So, stupid memory trick is if you just think about like the movies where they're like, we have to check the perimeter about what's, oh my goodness, about, they have to go around the entire thing. The perimeter is around the entire thing. It's like your boundaries. So, simplifying radicals. When we simplify radicals, you want to find either pairs or perfect squares. Goodness, I cannot write today. I don't know what my deal is. I am sorry if the video gets loud for a second. So pairs or perfect squares. And if you forget your perfect squares, it's like 4, 9, 16, 25, 36, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. So looking at 121, if you do not know off the top of your head that that is a perfect square, then you would want to break it down into 11 times 11. And then we have that perfect pair, so it gets to move out. And when it moves out, it goes away on the inside, and it becomes just 11. So for 150, I would need to break down 150 as much as I can. So I would start with, let's say, 15 times 10. 15 breaks into 3 times 5, and 10 breaks into 5 times 2. So for me, I see that I have a pair. They get to move out, and when they move out, they are no longer needed on the inside, and we have 3 times 2 left on the inside. So then 3 times 2 is 6. Ooh, my writing today. I am so sorry. So then for 142, 142, I know I can divide by 2. That gives me 71. Now, 71 is a prime number as far as I'm aware. 71 divided by 4. 71 divided by 5, that's obviously not going to work. 6, yeah, no, okay. 71 is definitely prime. So because this is a prime number and because I have no pairs or perfect squares, I'm just going to multiply these back together, and it's just the square root of 142. It is okay if your radical cannot be simplified. It happens. All right, so then if I wanted negative square root of 72, I know 72 breaks into 8 times 9. 8 breaks into 2 times 4. And 9, if you want to break it down, breaks into 3 times 3. Some people, though, you just take it out right away. But I have a perfect square, that is 4, so that 2 gets to move out. And then this pair of 3s also get to move out. Boop. So then I'm left with just 2 on the inside of the radical, and outside I have this 3 times 2. 3 times 2 is 6, and then this negative 1 in front would make this a negative 6. Okay, so then last but not least, we have 44. So 44 we can break into 4 times 11. I see my perfect square, I move it out, and I have 2 square root of 11. So one way to check your answers, if you want, is to take the number outside and square it. times your number inside. So, like the 5 square root of 6, I would square the 5, so 5 squared is 25, and then 25 times 6 gives me 150, which is what I started with, so that is what I want, so I am right. Okay? So, now into the actual graphing. For all of these, you want to give me the exact perimeter of these polygons. So, we'll start just by graphing. We have 4, 0, 1, 0, 1, oopsie, 1, 0. Ooh, that was bad. 1, 0, there we go. 4, 0, 1, 4, and 4, 4. So you notice it makes a rectangle. And in this case, we can find the area and the perimeter pretty easily because we can just count 3 and 4. So for perimeter, it's 2 times your length plus 2 times your width for a rectangle. So 2 times 3 plus 2 times 4. Oops. 2 times 3 is 6. 2 times 4 is 8. So we get that the perimeter is 14 units. So then to get area, that would be length times width. So 3 times 4, which gives me 12 units squared. And that one's your easy one. So now you're going to end up getting shapes that are not necessarily so easy to count or find the lengths of. So if I started, we'll use orange, and plotted these, we have -4, 1 is E, -2, 3, and -2, -4. So if I connect all of these, you can see that I have a triangle. Yay! Now with this triangle, if I want to find the perimeter of it, I'm going to have to know the length of all of the sides. Well, with FG, I can count that. That's 1, 2, 3, 4, 5, 6, 7. And then with EF and EG, I can't because it's a diagonal. So this is where you can either use distance formula or Pythagorean theorem. Just know that I'm going to be adding all of these lengths to it. So EF and EG. So if I start with EF, the simplest way is to use Pythagorean theorem because you've already have these on a graph. So that means I would have, if I were to draw in a little right triangle, this right triangle right here. And that is 2 by 2. So that would mean with Pythagorean theorem, I would have 2 squared plus 2 squared equals c squared. 2 squared is 4. 4 plus 4 is 8. And then we have to take the square root. Now, because I want exact, you're going to keep it in a radical. So this becomes 2 times 4, and that 4 comes out. So we have 2 root 2 for C. Okay. So then, to find EG, I would do the same exact thing. Make a little right triangle in here. We have 2 and 1, 2, 3, 4, 5. So then 2 squared plus 5 squared equals c squared. That gives me 4 plus 25. And 4 plus 25 is 29. And 29 is a prime number, so that just stays the square root of 29. So this is where if you want to have nice, pretty whole numbers as your answer, you're going to be really sad because we cannot combine these radicals. The only time you can combine radicals like square root of 29 and square root of 2 is if you had another one that was square root of 2 or square root of 29. Since the numbers inside the radical are not the same, we cannot combine them. So then our answer would be 7 plus 2 root 2 plus square root of 29. Okay, and that is the value. Again, this is the exact distance. If I wanted the rounded version, then you would actually do like 2 times the square root of 2. What is it? And then what's the square root of 29? And then you would add all the decimals up. So now I want to find the perimeter of this polygon. So I'm going, let's use the blue, -2, 4, 6, -2, 4, -4, and -6, -2. So again, we want to find all of these lengths. Because we want all of these lengths, organization is very, very helpful. So if I start with KL, I have a horizontal distance of 1, 2, 3, 4, 5, 6, 7, 8. Okay, making sure. And then a vertical distance of 1, 2, 3, 4, 5, 6. So then that would give me 6 squared plus 8 squared equals c squared. 6 squared is 36, 8 squared is 64, and that gives me 100. So then the square root of that is 10. Yay! So then we're going to do it again, except now we're going to do ML. So with ML, that is a 2 by 2 right triangle. So I would have 2 squared plus 2 squared equals c squared. That gives me 4 plus 4. And then we take the square root. And if you recall, the square root of 8 simplified is 2 root 2. Okay, so then continuing on, let's do some pink. Why not? Actually, the pink will blend in with that orange too much. We'll do the lime green, sure. So then if we want to do NM, we would have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then a vertical rise of 2. So then 10 squared plus 2 squared equals c squared. That gives us 100 plus 4, which is 104. And 104 can be divided by 4, I know, which is 26. So then this perfect square gets to move out. So then we have 2 root 26. Okay. So then, last but not least, we are going to have Kn. So with Kn, we have a rise of 1, 2, 3, 4, 5, 6, and a run of 1, 2, 3, 4. So this would be 6 squared plus 4 squared equals c squared. 36 plus 16. 36 plus 16 gives you 52. And when you take the square root of 52, 52 breaks into 2 times 26, and 26 breaks into 2 times 13. So then I have a pair of 2's that get to move out. That is 2 root 13. So then for perimeter, you are adding all these together. Again, I don't have any radicals that can combine with each other because none of them are the same. So you have square root 2 and square root 26, definitely not the same number. And then square root 13 is definitely not the same as root 2 or root 26. So then you just write it as an addition. 10 plus 2 root 2 plus 2 root 13 plus 2 root 26. Okay, and again, these answers might be ugly, but this is the exact distance. Okay, so then our last example, we want to draw all of these on here. So we're going to start, e is -1, -1, 2, -2, -1, -4, and -4, -3. So looking at it, it looks like this might be a parallelogram, but we want to make sure. So we just want to check the slope. If they have the same slope, then they are parallel. So looking, we have run of 2, rise of 2. Or sorry, run of 3, rise of 2. Rise of 2, run of 3. Those are parallel. And then rise of 1, run of 3, rise of 1, run of 3. So these are also parallel. So knowing that this is a parallelogram, we also know that these sides are the same. So I can actually find what EF is, and I can find what FG is, and then I can do my perimeter. So if I start with EF, that is up 1 and over 3. So my right triangle would be 1 squared plus 3 squared equals C squared. That gives me 1 plus 9, which is 10. And when you take the square root, we cannot simplify the square root of 10, so it just stays 10. So then, for FG, I go up 2 and over 3. So 2 squared plus 3 squared equals C squared. We have 4 plus 9 equals C squared. This gives us 13. And that gives us the square root of 13. Again, can't simplify. Now, because I want perimeter, and this is a parallelogram, I need 2 of my lengths and 2 of my widths, or 2 of my bases. So that becomes 2 root 10 plus 2 root 13. And if you actually wrote out the long way, like root 10 plus root 10 plus root 13 plus root 13, it still would simplify because the ones in front of each of these would just make those 2's. Okay, so that is the end, and this looks ugly, so I'm going to erase it. But that is the end. So the homework is on page 707 in the textbook. And you only have to find perimeter. So even if the directions in the book say to find the area, only find perimeter. So if this video was helpful or anything, feel free to like and subscribe. It is always appreciated. And we'll see you for the Unit 1 review.